All right, guys. How are we feeling about integration so far?
Really good.
All right, right about this time, I usually I feel really good, or I get this look like this wide-eyed, I don't know what the heck's going on, but I'm not going to do anything about it look. You got to do something about it. I'll be here after school for a little bit if you want to come here and talk before the break. Once you get it, now I'm going to listen, the problems I'm going to throw at you today are very rare. Like honestly, they show up. I'll have one of each kind on my test. I'll tell you up front now, it's pretty easy to identify, but they're not pleasant, okay? I'm just not gonna lie to you. It's one of those things, honestly, I have people every year that go, yeah, I'm just not gonna worry about this topic when it comes to the AP test. And they just go, I'm gonna take my chances. And a lot of times it doesn't show up. It certainly didn't show up last year. But in most years, probably one or two of these kinds of integration problems will just show up. And if you understand how to do them, it's not a big deal. And it's kind of identifiable because you know how yesterday when I gave you those situations and we were talking about U substitution and we went to try U substitution and it didn't work? And I said at that point you need to hear that, wait, it's inverse, Tim. All right, this is another one of those and I'm going to show it to you. The first one I'm going to show you is U substitution. And then I'm going to show you how the next one you're going to go, wait a minute. U substitution wouldn't work. So, but it won't be an inverse. So it's just one more thing to kind of remember. So what if I gave you this? Got my nice workout. So it clearly is not an inverse tree. It's not even a fraction. Now if I gave you this, it certainly doesn't look like anything on your rule sheet. And again, I cannot emphasize enough to you that you have to learn all of those rules on that sheet front and back, okay? Except the ones I told you to omit. And I'm going to give you a quiz that's going to look almost exactly like the one you took yesterday. And if you're at home, all I did was give them a sheet that I just checked the actual rules on the sheet. So there was literally, if you can look at the integral on your little formula sheet and write down the answer, that's all I had yesterday. But what I'm going to do this time is it's going to be the rules, but instead of having x in there, it might be 3x minus 1. Instead of having tangent of, or whatever, sine of 5x or x, it might be sine of 4x. So it's going to require a small u substitution each time. It's not going to be a real ugly looking u substitution like this, because it will probably be a more identifiable rule. But again, instead of having something like the integral of 5 to the x dx, which we probably know is 5x over ln 5, it might be something like the integral of 5 to the 4x minus 1 dx, where you would have to make a u substitution and then a du substitution to be able to do it. That's what your quiz will look like on Monday. Are y'all with me? But that's real. I'm not going to make it brutal questions like you've been seeing throughout your homework. Just, again, I'm checking the rules, making sure that you got this down. So back to this. What would you do in a problem like this, since it doesn't look like anything?
Assume a position.
And that never ends well, never ends well. So you're going to take a random guess on u substitution, and normally my random guesses are, if it's a fraction, try the denominator for the u. If it's got multiple parts, try the one with the biggest power. Usually that's how it plays out, right? And you can see that the biggest power is the one on the inside, right? So I'm going to try that part right there as my u. And then conveniently when I take the derivative, du dx is 4x, swing up the dx. And that works out pretty well for me because my du is that, and I can see that there's an x dx, right? And I can put a 4 in there and a 1/4. And then you'll see on all my homework problems that I've worked out, I kind of circle stuff. So when you think about what I've done here, I carry over what's not circled, which is the integral and the 1/4. The square root part is not circled. The u is on the inside, and all the rest is the du. And it looks like I have just created a power rule problem. So I think about that as 1/4 integral of u to the half. Don't forget the du's if you're getting the habit of forgetting those. And then the integration says out of 1, right? And then to divide by 3/2, we multiply by a 2/3. And that Don't forget a plus c. At this point, some of that cleans up. 1/6 u to the 3/2 plus c. Plug your u back in. Are you with me? Now, that's what we already know. So what's going to happen today is you're going to see a problem that looks almost exactly like this, but you're going to immediately see, or if not immediately, you'll see when you start the u substitution that something goes wrong. So check this out. Same problem, like literally same exact problem as this, but instead of 2x squared, it's just 2x. Huh. Now again, my goal is to create a rule. I mean, make it fit one of the rules on my sheet, and if I can do that, I'm okay. And yes, my initial thought would be probably to do that, right? But the problem is, when I find du, I get 2 dx. And when I go to circle stuff, 2x minus 1 is fine. 2x dx ends up working. I'm sorry, the 2 I can put in there, times 2 times a half. But the problem is I'm going to have a square root of u du with an extra x sitting out there. And that I can't have. So what can I do?
You can multiply the egg on the outside into the radical.
Okay, good thought, actually. It's not going to work, but let's think about it for a second. But I like the thinking. An x on the outside really came from a x squared on the inside. If I did that, and listen, it's worth a try, I like creativity. X squared on the inside would give me 2x cubed minus x squared, right? And the problem is, I have all of that to the 1/2 power, but that's not a rule. I got this 2x cubed in there. And if I try to make that my u now, then my du ends up being 6x squared minus 2x dx. And I don't have that, do I? So it was a good try, didn't work, that's okay. We call this process u substitution. It's just an uglier, well, I'll just say an ugly u substitution. My words. Because textbooks don't go around saying that's the ugly version. All right? But it's just an uglier version. So what we're going to do is we're going to do the u substitution like I've done here, but I'm going to replace x with what it's equal to in terms of u. I can solve for x here. So what happens if I take this and solve for x? What do I get? U plus 1 over 2? Is everybody with me on that? And I'm going to plug that right there in for my x. Now at first glance you're like, how does that even help us? And it goes back to what Nolan said. Okay? You didn't even know how great an idea he had. Now check this out. He's like, yeah. Okay, check it out. I got 1/2 integral. I'm going to plug that in here for this x, which at first glance you think that's not helpful. I'm going to have the square root of u now, and then du. Now, you might look at this and go, how is that any better than your original problem? Okay, so let me show you the original problem again. The problem with the original problem, because when you look at it, you're like, how is something times a radical any different than something times a radical? And the thing is, me with this, multiplying the x in, or bringing it in, put everything under the radical, didn't it? And that was terrible because we tried the u substitution, it didn't work here. Because there's more than one term under there. But now that I've kind of switched positions, now instead of having a monomial here and a bunch of junk there, now I got one number here and a bunch of junk here. And the advantage of that is, I can now distribute this in, and I'll have a bunch of powers. Now, the 2 is kind of bothering me here, but it's a constant, right? So I'm just going to pull that out for now. I mean, you could leave it in there and call it u over 2 and 1 over 2, but I'd rather just bring it out. And what is u to the first times u to the half? Does everybody see that? That's u to the 3/2? And what is 1 times u to the half? And now I have a power rule. Now, this is rare. It really is. But it's really just called u substitution. I mean, it would fall into just the heading, but because it's so rare, I kind of isolate it on a day and say, hey, this is, and most of the time you see these, that shows up with radicals. So that's another little red flag. When I see these on AP tests, it is almost always, maybe once in 20 tests I've taken, have I seen one of these that didn't have a radical. But this is normally how it shows up. So, at this point, I'm okay, right? I got 1/4 on the outside of everything, and this is why it's important to put 1/4 on the outside of whatever we're doing here. So what do I do here? U to the 5/2 divide by a 5/2 is multiplied by 2/5 plus u to the 3/2 2/3, and then when you're finished, you end up with 2/20 or 1/10. I'm distributing this in u to the 5/2. And then that times that is 2/12 or 1/6 u to the 3/2 plus c, and then take your u and plug it in. So it's just basically a two-step u substitution, but it is a last or second to last resort. It rarely happens. These show up less than the inverse trig things. So again, if you're one of those who's like, I'm really, really bright and capable of a 5, but 4 suits my purposes, then you probably have a little bit more wiggle room on saying, I'll take a mulligan here or there or whatever. Or maybe, hey, I'm going to Auburn, I'm going to be in political science. All I need is a math class, a 3 will do me just fine. You know, maybe you got a little bit more freedom to go, I don't need to know these. But if you really want to shoot for 5, and I kind of like the idea of being able to tell your kids, you know, for however many years from now you have kids, you can go, oh, suck it up. I made a 5 on this thing. You can make a 5. You know, it's like the whole I walked uphill to school both ways, through the snow, barefoot. Do what?
Monkey see, monkey do.
Sure. Are y'all with me on this? All right, let me show you another one, because again, these are kind of strange looking. How about, this one has a radical, but it throws a fraction in there also. Do what?
You just want to brag that you can get a 5.
Yeah, I didn't take the AP test. We didn't have calculus when I was in school. The only AP class you could take was AP.
Wait, when did Isaac Newton?
Do what?
When did Isaac Newton die?
What?
No. We had calculus, the topic, but they didn't offer it in my high school. No. In my high school, you took analysis. You took analysis. Actually, it's not completely
So
true.
you were in the analytical?
Now, I have my textbook still. I have a whole set of them I found in the school. They're about to throw them out. I'm like, ooh, I'll take those. One day I'm going to sell them on eBay, because they go on eBay for like $2.50 a piece. I don't think they sell very often, but anyway, this textbook, we did all kinds of stuff like logic, some things that really are positive. Like, they don't teach logic in schools anymore, but it's really something they ought to, because people are so illogical. But my senior year, they offered calculus, but the problem was nobody took Algebra 1 in 8th grade like you guys do to prepare you. So the advanced kids were taking analysis, which is basically pre-cal with other topics their senior year. And they offered it, and I went to the biggest high school in the state at the time, and 4 kids who were at private schools in junior high who were ahead were able to take it. So that was the first year. So the kids who were the smart kids, I mean, back then you only needed 2 math classes to graduate in high school. That's it. So if you hated math, like my wife took Algebra 1 and geometry. She was an art major in college. So she didn't even have to bother taking math back then. So now that you have to take so much, most people are tracked a little earlier. We don't track, but most people take that Algebra 1 in, 8th grade? And then 9th grade, everybody's in geometry or whatever. All right, here's another one. How about this? But yeah, my first calculus class was in college. What if you have this? Now, like in any fraction, I will almost always, with the exception of maybe a natural log involved, I will almost always pick the denominator, okay? Now, in this case, if I pick the entire denominator, then I get a mess, right? Like if I said this was my u, then my du ends up being what? All of that. And I'm like, that doesn't work out for me a bit. So I'm not going to take all of it, I'm just going to take that part. But the problem is, if that's u, then du is 1 dx, or just dx. Well, that takes care of this, okay? And by the way, I forgot the dx on that, sorry, put that in there. And that takes care of this, but I still have that extra x on top, right? But how can I fix it? So if that is true, then x is equal to u minus 3, right? And I can replace that x with a u minus 3. And let's just hope something nice happens. I think it's going to happen nicely, because what's going to happen is the bottom, instead of having a binomial in that radical, now I'm going to have a monomial in there, and I can treat it like a single power, like u to the half. Whereas I can't really do that now. So check it out. I have now the integral of 2 times my new version of x minus 1. But now instead of having a square root of a bigger number, I just have a square root of u. And then du. I'm going to move this over here just for easy. So now let's see if I can clean this junk up. This really is 2u minus 6 minus 1. And that's u to the 1/2, right? Well, can't I do this and write this as a power rule then? So what is 2 to the u over u to the 1/2? What do I do when I divide like bases? Subtract exponents, that gives me a 1/2. And then right here, 7 over that, there's not really a u there, but can't you just swing that u up and call it 7u to the negative 1/2? And now you've written it as a couple product rules. So we integrate each part. Nice thing is there's nothing out front, so I don't have to worry about distributing that in. So I get 2u to the 3/2 divided by 3/2 is times 2/3. And then minus 7u to the 1/2. To divide by a half, I multiply by a 2. Take my u, throw it in there. Don't forget a plus c, and then I would probably clean it up and call it 4/3 and 14. You tracking with me? Now, this is not normal. Again, this is one of those, most of the time, u substitution works, right? It just does. You do your substitution, magically everything works out cleverly, and you get to the end, you're like, oh, it fits this rule. If you ever try to use substitution and it doesn't work, then think, maybe it's an inverse trig, maybe it's one of these. Obviously, your name's not Tim. Maybe it's a inverse trig, maybe it's one of these ugly u substitutions, or maybe it's one of these I'm about to show you. So this is the ugly u part, and here's the second thing I want to show you. Super ugly. No, this is, I'm going to say this and I'll probably hear a collective groan, but do y'all remember long division of polynomials?
Yeah.
Okay, and most of the time, if you're like me, when you did long division, you had this polynomial into a really high-powered polynomial, and you had to do like 10 steps all the way down, and it got really nauseating, and you had to change the signs. I don't remember me doing that kind of thing. But I'll walk you through one as we do it. But normally the powers only differ by a couple, so it's only a couple steps. But let me show you what I'm talking about. And then these are pretty easy to identify also. But again, and you'll see it almost immediately when you try to do u substitution. But it always occurs with fractions. So you can see fractions sometimes are the problem. And they have to be carefully engineered. So just eyeballing this, it doesn't look too bad from the beginning. You're like, oh, it's probably u substitution. And then you look again and you go, wait a minute. for a u substitution to work, what pretty much needs to happen? Say it,
Like it needs to be in the denominator.
what needs to be in the denominator?
U substitution.
So I could still do that, but what's the problem with me choosing that as a u? The power is going to drop. So normally when a u substitution works in a fraction, the power in the numerator would have to be smaller. So that's the red flag. If you see a fraction, and again, unless it's involving a natural log whose derivative is in the denominator, right? The derivative of natural log of blah is 1 over blah. So unless that happens, if you see a power that's the same, because again, and you can see it right here, if I were to take the bottom and call it u, my du is going to be a lower power. So if the top power is the same or higher, you can't do it. A u substitution is not going to work here, and an ugly u substitution isn't either. Because if I take the top part to be a u, when I take the derivative is not in the denominator, is it? I mean, look, if I let u be the top part, even if it did match, which it doesn't, even if you were sitting on a 4x cubed plus 3 down there, even if it was, it's really a 1 over 4x cubed plus 3 dx. Are you with me? And this is not a 1 over, this is a over. So the point is, in a situation like this, what you have to do just to get to the point that you can actually do the long division, do the integration, is to do long division. And if you remember about long division, what normally happens? When you do the long, and I'll show you, when you do the long division, you get a bunch of individual terms, and then a little smaller remainder, right? Well, then the smaller the remainder, you'll be able to do with long division. With u substitution. Because once you divide, what you end up with is a smaller power on the top, back to where you like it. Are you kind of tracking with me?
Yes.
So let's just try it. Here's your long division. I'll do it over here. So you've got x squared minus x plus 1. Now, were there a couple of things you got to remember about long division? What happens if you're missing a term?
You drop it.
0 for the x cubed, 0 for the x squared, 3x minus 1. You got to remember to do that. Right? Make sure that this is catching this. Yeah. All right, so what's the process again? What do you multiply by x squared to get an x to the fourth? So you put that there, and then you go x squared times all of this, right? So that would give me an x to the fourth, which we line up under the x to the fourth term, a negative x cubed, which we line up under what would have been the cubed term, and a positive x squared, which we line up there. And then what do? We subtract that by changing the signs. And that gives you 0, positive x cubed, negative x squared, and we drop the 3x. And then we repeat the process a couple more times. X squared times what gives me an x cubed? An x. Multiply the x by this. X cubed minus x squared plus x. And then what do? Change the signs. And I get 0, 0 again, 2x, and a minus 1 when I drop it. Well, the second what I have left has a smaller power than this, I'm done. And the way I would have written this is plus 2x minus 1 over that. Right? And we did this in Algebra 2, and you're like, why would I ever do this? This is one of the reasons. So what that means is that this fraction is equal to that number. So I am now going to rewrite this as the integral of all of that. And now when I integrate each part of this, when I get to this part, what do you notice? The bottom part has a higher power than the top. I bet a u substitution is going to work nicely. Now you'll look at this one and you're like, oh, what a coincidence. When I take the derivative, I get 2x minus 1. Well, yeah, we had to work really hard at this fraction to make this happen. But that kind of coincidence happens in Cal 1. So what's the integral of x squared? X cubed over 3. And the integral of x, x squared over 2. And then the integral of this, I'm going to go ahead and just write integral of that because I'm gonna have to take a couple of seconds to do a u substitution here. So what would my u be? X squared minus x plus 1. My du is 2x minus 1 dx. And by the way, when you write 2x minus 1 dx, it really means like the parentheses 2x minus 1 dx. Well, there's my u, there's my du. So this part right here we go, x cubed over 3 plus x squared over 2 is really an integral of 1 over u du problem, isn't it? So what do I finally end up with? X cubed over 3 plus x squared over 2 plus, what's the integral of 1 over u? The natural log of the absolute value of u plus c. And honestly, more than not, these problems end up with that as your last term, because it normally ends up in a situation like this. Now, there are some dirty ones out there, and I think I throw one really dirty one at you on homework, just to see, because you actually get down to here and you have to do like a ugly u substitution or something other really creative. But that's not the kind of stuff that shows up in my test. If one of these shows up on a test, it'll be pretty straightforward. You'll look at it, the powers will either be bigger on the top or the same, because either way a u substitution wouldn't work immediately. And then all you have to do is do the long division and then integrate the results. And if it didn't come out pretty in the end, you probably need to go back and check this. Maybe you made a careless error. Want to see another?
I got a quick question.
Yeah.
So like if the powers were the same on the top and the bottom, like would it possibly be better to try and factor?
Well, anytime if you were able to factor it and cancel something out, yeah, it might make your life a whole lot better.
Okay.
Yeah, I would never rule that out, but I don't know that I've ever seen one that's worked that way. AP rarely will give you a question that they used to all the time. The algebra they used to put on tests was awful back in the 70s, early 80s, and you've seen a couple of those problems. I tried to weed most of that out because it just is disheartening, because you're like, good night, the algebra's brutal. They really have eliminated a lot of that, and mainly because calculators entered the picture, but they've really cut down a whole lot on the problems that you required more algebra than they did. You see it, the factoring you see on these kind of problems, like finding critical numbers, all that kind of stuff. You're not factoring 4-term polynomials or differences of cubes, and it's just really basic algebra, and then they really test the calculus. All right, here's one that has a powers that are the same on the top and the bottom, which makes the synthetic or the long division pretty easy. Oh, and if you're thinking, could I do synthetic division? When does synthetic division work? When there's like an x to the first that you're dividing by. So any power bigger than 1, you can't do synthetic division. So most of these will be long division problems. So this one, I look at it, you kind of look for a second, you're like, wait a minute, if I did a u substitution, I get a 2x as my u and or my du, and that's not going to work up here, that's x squared. So you think, oh yeah, you remember long division when the powers are the same or bigger on the top. So this one, x squared plus 0x plus 1 into x squared plus x plus 1. And this is not going to take just but a step or whatever. So x squared plus times what gives me that? 1. 1 times this gives me x squared. Change my signs and what happens? I get x plus 0. And the second I'm smaller here than I am here, I stop and put the x over that. So that means that this is the same as 1 plus x over x squared plus 1 dx. Well, integrating the 1's easy. What happens when you integrate a constant? You get a constant times x. And then what happens when you integrate this next part? What would you probably do? I would do a u substitution. So that part was easy. This part, u equals x squared plus 1, du equals 2x dx. Can I fix that? 2x 1/2. So I get x plus 1/2. Integrate. There's my du. There's my u. And again, you end up with that 1 over u situation, which is almost always the case. So x plus 1/2 times ln absolute value of your u, and you're out. Not too bad.
You just got to avoid that.
Wow,
They were killing troops.
that's so sad.
Y'all want to see anything else? You want to start working on your homework?
Yeah.
Will you work on it?
Yeah.
Okay. All right. Work on your homework, and if you get stuck on something, say something. We'll take a look at it.